All right, quiz one. Most reactive to least reactive. So this one was looking for folks to think about, right, bonding, right, how things bond, and about size. So for this one, I2 is the most reactive, and then F2 is the least reactive. And really all it is about is because iodine is so large, these two atoms can't really connect that well or overlap that well, share their electrons that well. And so that's what makes this more reactive. Another way you could think about it is if this bond broke and you had I minus, that could be more stable too. So some people thought of it that way. Some people talk about nuclear distance, all sorts of things, but really this is what I was looking for. And I really wanted a picture, right? If I say draw a picture, you gotta draw a picture. Make sure you do follow, carefully read those directions. For this one, hybridization states. So all the nitrogens are actually sp2 hybridized. So this is adenine. All the nitrogens are sp2 hybridized. All the lone pairs, Bill did a great job on that. Label the hybrid orbitals on each pair of the nitrogen. So again, I've always talked about hybridization state is in a box, and the hybrid orbitals are not. So you should be doing those kind of things. So p orbital, sp2, sp2, p, sp2. This is next to a pi bond, so that's why this nitrogen's sp2 and this lone pair is in a p orbital. Anything that's sp2 can't do resonance. So these two can do resonance. And then I asked for the least reactive base. So which one of these nitrogens is the least reactive? A lot of folks had it narrowed down to least reactive because these would all be, sp2s would all be more reactive. A lot of folks had it narrowed down between these two. And this one's less reactive because they both can do resonance, but this one's doing resonance in an aromatic ring, right? As part of an aromatic system. So that actually makes it less reactive. So that's why that one will be the least basic one. All right, so COVID antiviral oral treatment, Vandentanib. First, just draw the lone pairs. So, right, these are, again, recognizing where the lone pairs are at. Nitrogen has 1, oxygen has 2, fluorine and bromine both have 3. And then draw 2 different resonance structures. So which atoms can do resonance? So let's just go through here. So this nitrogen could not, right? Because there's not next to any pi bond. So this is actually an sp3 hybridized nitrogen. This oxygen could, because it could push electrons into the ring. This oxygen could. This nitrogen, that lone pair cannot. This lone pair cannot. Now, these electrons could come here and break that, right? But this lone pair and this lone pair are both in sp2 hybrid orbitals. So they cannot do resonance. This nitrogen could, the fluorine could, and the bromine could. Now, the fluorine and bromine, just because they can doesn't mean they want to, right? These are actually electron withdrawing groups, so not very likely to do resonance, but they could. Nitrogen and oxygen are much more electron donating, so these are activators, so they could.